Hello, everyone. Just to now say that we are going to start afternoon session. My name is Rémi Demerlet. I'm working for Semtech in the vertical of utilities. And I'm very pleased today to welcome on stage three eminent companies having interesting use case with utilities. So first of all, let me introduce you to Maurice Zembra for vertical end-to-end, Massimo from Proesys, that is arriving, and Orse from NetOp technology. Please have a seat. And Maurice, you will start with presentation of your use cases.
Okay. Hello, everybody. My name is Maurice Zembra. I'm from Vertical M2M. I'm going to explain what we can bring on the market with utility market. First of all, I will make a quick introduction about our company. We've been active in the IoT world for more than 10 years from now, and in the LoRaWAN space also for more than 4 years, but we only recently joined the LoRa Alliance, so we are very happy to be here with you today. We are a telecom software vendor. We are providing an IoT platform that covers most of the issues that industrial players may face when deploying large-scale IoT solutions. The first one is manage heterogeneity of devices and networks. The second thing is to be able to scale the management as if it were done in the telecom industry, so to do the same thing as in the telecom industry. And the third thing is, of course, because it's all about use cases, is the ability to integrate any application, any business layer, and so to be integratable with applications, whether it is done on the platform itself or outside the platform. So we started getting interest in the smart water industry only 1 year ago. We already have a large range of products that have been LoRaWAN products that have been integrated with our platform. But we consider as one of our main markets, the smart water industry as a very interesting market. First of all, because of course it's a crucial issue for everyone. It's a crucial issue because of ROI issues. Of course, you have huge water leaks that are supported today, and you also have, of course, issues related to sustainable development that need to be addressed. Considering all the technologies that were available on the marketplace, we found much relevance with LoRaWAN for several purposes, for several reasons. One of them, of course, was the ability to provide a full ecosystem of products, because when you are targeting smart water issues and smart water industry, you not only need to have smart meters, but you also need to have valves, to have sensors, so a full range of a full portfolio of products, and this is what is available today on the LoRaWAN, with the LoRaWAN Alliance. Second thing is, of course, the deep penetration, deep indoor issues, because many of the meters that are installed are underground or very difficult to be accessible. You also have the issue with low consumption and long-lasting battery. And also another issue that we made and that was solved by the LoRaWAN technology is the ability to address both public and private network opportunities. Because in some cases, in some deployments, you want to rely on a public network. In other situations, you may need or you may consider having your own private network. And the ability to do both is very exciting with LoRaWAN. So I will just highlight two of the smart water use cases we did so far. One of them is with a customer called Réunion Télérelève. It is based in the far away in the island of Réunion in France. They are currently part of an engineering group that works exclusively on the water market. They are doing installation, water pipes, and so on. And they addressed a typical use case where they had some property managers that had an issue with the water leakages on their buildings. They had lost, they lost among almost 30k euro a year on each building. So they needed to have something that helped them monitor the water leakages and reduce them. And so that's what they did with us, deploying a network on the island with a number of gateways and using a range of meters, mostly Madalena water meters, and a set of different products put together with our platform, Common Sense IoT platform, in order to be able to provide a full application based on LoRaWAN and to provide the ability to monitor everything related to water. So this is the first use case we had. The second one is another company. So they are not concerned with buildings. They are rather concerned with a large number of different kind of customers involved in water markets. So they are working with industrial customers, with agricultural customers, and residential customers for cities. And they are providing water treatment and water management for them. And they needed a solution where they had to put together different kind of sensors, of course meters, but not only meters, different kind of sensors in order to improve the management of their network. And so that's what they did with the solution. Okay.
And now I will invite NetOp to present a use case. And of course, to start with the introduction of your company and your activities.
Thank you very much. I'm from NetOp Technology. I am co-founder and CEO of NetOp. Actually, I am in IoT business more than 15 years. I saw some dinosaurs like me. We called it telemetry when we started. Then it called M2M. Now it's called IoT, IoE, IIoT. I don't care the name of it. I am collecting data and send it to cloud for more than 15 years. And in these years, I saw that nearly every IoT project going tailor-made. That's why I started to find a way to arrange a hardware architecture that can fit all kind of IoT projects. And I patented, based on LP1 connectivity, my hardware architecture. And now I focused on verticals. This one is one of our verticals. We are trying to monitor and analyze low power electricity distribution networks. It's nearly the same. Nowadays, there are many samples in the market. You have to know home monitoring tools. It is a device which will install entrance of the home, and you can monitor from your smartphone what kind of consumption going on at home. This is nearly the same, but we are doing the same for the whole city, not only for exact home. How can we do it? How can we start it? Actually, most of the electricity distribution companies doesn't know what's going on in the city because they are monitoring all the grid with big SCADA systems till substations. But after substations, they did not know what's going on. And most of the cases occur after the substations. That's what we are doing. We are monitoring substations. We have a device, we called it Octopus. There are many legs on it. Have you ever seen inside of the substation? They called it feeders. Feeders goes to the streets and feed with the electricity all the streets. Minimum 10 or 8 feeders per substation. And they are trying to feed all streets. What we are doing, we are clamped to the feeders with our sensors and monitoring in real time all electricity consumption. And at the backbone, we have a huge artificial intelligence system monitoring, analyzing what's going on. And from now on, we have more than 20 different data patterns in our hand, can understand what's going on in the city. Let me try to introduce you a use case from Netherlands. Especially in Netherlands, it's a still big problem, indoor cannabis farming. If you want to make indoor cannabis farming, you have to use some special bulbs which are simulating sun. And this kind of bulbs going to sign to electricity grid with a unique signature. And our system, our artificial intelligence system, monitor electricity consumption and look for this signature. If it finds a signature like that, then it sends some information to somewhere, to police department, to wherever I don't care after this notice. And this system still using in Netherlands, and as you remember, I started electricity distribution company knows nothing. Now they transform, let me say, with the fashionable word, digital transforming from knows nothing to predictive. For example, another use case, did you remember the Notre Dame Cathedral fire? If this city was used our system, we can also predict somewhere in the city there was a electricity short circuit and notice somewhere. Of course, I could not prevent the fire, but I can notice as early as possible. Now what we are doing, the next step, we are trying to work on algorithms that can notice where things happen. And it will add more and more feature into our system. That's all.
Thank you.
Thank you very much.
I know Massimo, CTO from Proesys. Please, welcome.
Thank you. Okay. Good afternoon, everybody. I am Massimo Marini, the CTO of Proesys. Okay. We will focus today on structural monitoring issues. Our company is focused on the design and production of LoRaWAN sensors and gateways. And we approach the vertical market focusing on the monitoring of structural integrity of critical infrastructures. Here we present a use case for the monitoring of high voltage tower lines, where we have issues of structural integrity and also physical attack or sabotage to the tower lines. So we have developed a sensor that integrates a high accuracy inclinometer and a vibration sensor And we have developed a lot of signal processing algorithms inside the sensor to discriminate resonant frequencies or self-resonances of the tower line, of the tower, to discriminate from physical attack or copper theft or somebody climbing on the tower. So that's the main goal of knowing nothing, as the other colleague said, to know exactly where, which tower had a structural failure or is being attacked, maybe for sabotage or for copper theft. So this, you can see an analysis, a frequency analysis here, where it's possible to discriminate self-resonance from physical attack of the tower. Okay, this is a photo of the sensor that is very easily attached to the tower, and it mounts in 5 minutes, and it lasts on battery for approximately 10 years. So has a very, very low maintenance, and it's entirely self-contained and autonomous in sending alarms to the control center. We complete this solution with our gateways that provide hopping capabilities. This is a typical use case where the gateway is isolated. And so there's no internet connection, no power available. So we have developed a special solution for making a mesh network between gateways up to the substation where we have internet connection. So the main advantages of the LoRaWAN technology for this kind of customers, we also include the railways in this class of customer that has also similar problems. LoRaWAN has the advantage of the long range and low power. This is clear to everybody, but especially for monitoring rural areas and critical infrastructure that are usually located in areas where there is no cellular or very poor cellular coverage. LoRaWAN is ideal for bringing connectivity to remote areas. So another key point is that the customer can have full control on its own network, which is a usual requirement for critical infrastructures. So from sensor to the network server to the application server, the customer can have full control of its own network elements. There's a high level of cybersecurity in the entire chain, from the sensor to the application server. And these are all benefits that the LoRaWAN solution can bring for critical infrastructure monitoring. We can change parameters online almost in real time. We can change keys. And of course, the benefit of being a standard protocol. So customers can mix sensors from different vendors and have the compatibility guaranteed.
Thank you very much for your presentation. We will continue with questions. First, questions for each individual, each company, and then after we will leave the audience to ask questions. To start with, and to get deeper into the understanding how you've managed to create a solution and to address the needs of your customers. I wanted to get back to the value proposal of the beginning. For vertical M2M, you presented the common sense platform,
yeah.
And the fact that you had a catalog of 150 LoRaWAN devices. For you, how that is an important effort? Can you explain more what was your strategy in getting this catalog of devices ready for customers?
Yeah, okay. So of course it's a key to have a set of devices that will address all the use cases that the customers need. So in order to build this catalog, this portfolio of products, we rely on two things. First of all, of course, we have been working in the LoRaWAN space for more than 4 years, so we have built relationships, strong relationships with many device makers, product makers, in order to have a strong ecosystem. This is very key. And second thing, we rely on the capability of our own platform, which supports a powerful scripting engine. So with this engine, you can very easily integrate a new sensor, a new meter, or whatever is the product. But not only with the uplink capabilities, but all the downlink capabilities, the multicast, and whatever. And all can be done by scripting, and you can even add calculation, real-time calculation if you want to improve data. For instance, for the smart water market, you may need to have very pure data, so you need to delete some double information. You need to discard bad information that you may receive through transmission and so on. So we can make some additional value and bring additional value on top of the single device. But for sure, to answer to reply, it's really a key aspect of the solution to be able to provide the right sensor for the right use case.
Okay, and still in the use cases you presented, it looks like you have used just a small number of manufacturers. Yeah. Same water meter, same pulse reader, etc. Is there a specific reason or is there a contradiction that you have a long catalog and at the end what the customer really need is only based on few sensors?
No, it's only a matter of the way they start. For instance, for Réunion Télérelève, the first use case was based on water leakage management. So they needed first to have water meters, then to build some algorithms based on the platform in order to fix and to find where were the possible risks. And then after this, they started to add some devices. So they are adding more and more devices, valves, Strega valves, and other sensors in order to manage water treatment plants with Modbus modules, Modbus and LoRa modules, and so on. So the way we did was very sequential because it was the way they were working on. So it really depends on the customer. In this industry, we think that we are doing better if we focus on the first use case and second one and the third one. But of course, if we talk with a telecom operator or a service provider, they will have a range of use cases that will run simultaneously, and then they will find immediately the benefit of having a full catalog of products already implemented and supported.
And of course, a tricky question: do you require certification for LoRaWAN devices?
Okay, I think we had this discussion before. I think it's really a good thing because if we want to scale the projects, we need to bring trust for customers. So certification will give a tribute to that and will guarantee in some ways for the customers that the device will be fully working for the long term, because generally smart water projects are long-term projects over 10 or 15 years. So, of course, having a certification, we already have in our platform what we call common sense ready devices with different certification levels. But having the certification from the LoRaWAN Alliance is, of course, an even improved and better an enhancement of the whole vision of the product.
Now, for Olsey, I wanted to explore further. You developed yourself the device that helps to connect from the substation and to after run the algorithm to perform the pattern recognition. You developed this device for some reason. Did you find similar devices on the market, or did not you find anything?
Actually, in our portfolio, we have more than 100 different sensors and devices based on LoRaWAN. But of course, this one is very specific for this vertical solution. Okay. Of course, when we when our customer came to us with this problem, we have to look what's going on in the market. And of course, we could find something similar. But most of the sensors have no connectivity. Even if you can find any connectivity, it's based on GSM or something else. And it doesn't fit. As I told, there are minimum 10 different feeders in the substation, and it's very hard to handle with GSM connectivity. Imagine that one substation has 10 different feeders. Every feeders have 3 phases plus 1 earth. It means you need 40 different sensors per substation. For example, my first customer had 4,000 substations in the city. It means 4,000 times 12 need SIM cards. And it's very huge and it's not affordable. That's why LoRa connectivity is very, very suitable for us. And we develop our own device for this vertical solution. That's why.
And for Proesys, you have also developed yourself in the company this device for pylon monitoring.
Yes.
Was it a result of non-finding any device suitable, or is it because of connectivity choice?
Both. Basically, we could not find anything similar, so we decided to develop ourselves a very specific sensor by choosing the right combination of electronics, algorithm for signal classification, and connectivity. As I said, LoRaWAN is a very good opportunity for remote areas, just like the ones that needs to be covered, high mountains, low valleys, and where there is actually very poor cellular connectivity. And we were able to achieve 10 years lifetime, so a very low maintenance rate of the sensor, just by designing our own with our own power saving and data logging capabilities.
So this experience proved the combination of efforts from electronics to connectivity and to bring after value from the data by algorithm. So you're combining different technologies. Could you each share how many employees you have in your companies, respectively, Maurice?
Yeah, we are 15
15 or say?
20.
20?
People?
Yeah.
8.
And okay, I guess most of the workforce is engineering.
Yeah.
So we have seen this morning presentation of a large use case for water metering. And the example of Réunion Télérelève is another kind of deployment of network to support smart water metering, but also more than this, monitoring of...
Many other use cases for cities and very different use cases. Because having a network they are expecting to have around 350 gateways installed on the whole island by the end of next year. So it will mean that they will be covering the whole island and they will be able to do asset tracking and many other use cases as well. But of course, the departure point was...
the start point was water?
Yeah.
Okay. So today you're enabling for them the network connectivity, and you provide platform plus assistance for devices, so to speak, in selection and integration. The relationship with that kind of utility, can you describe what kind of relationship from, I would say, small size company to a utility that is established, that has also perhaps access to local players, and you were far away from, I would say, their premises, because your premises are in Paris.
Yeah.
How did you manage the relationship?
Okay, today very easily because we use web conferencing, we use many tools, available collaborative tools that are on the marketplace, and what makes the difference is the expertise that we can bring to them. They rely on us because we are able to talk about the whole picture from the device up to the application. We can support them on the whole architecture, and even if we are providing the platform, we can help them find the devices. That's what we did with most of the customers we have today. We advise them on the network side, and depending on the use case, private networks may be the solution rather than public network. Both are possible, and that's one of the interests of the technology as well. And then on the application side, they can do many things directly on the platform itself because we have a design engine and they can publish applications, but they can also connect existing solutions for billing purposes, for other purposes of if they already have a vertical application. We think that we really need to be open and flexible with respect to that, and that's the reason why they chose to work with us rather than working with maybe local players.
And for Proesys, we understood that you're addressing a critical need to monitor critical infrastructure. So you're dealing with a big utility. How that was possible? What was the start point?
Yes, good question. We are usually seen as a design partner that can do very specialized products like this one that we have developed. And we team with system integrators that take care of the installation. And we participate together with the public utility and the system integrator to the definition of the specification. So we have good partners to complete our solution and our scope of supply with a full turnkey solution.
And who introduced the idea to use LoRaWAN?
We were the
pusher.
The pusher, exactly, of the LoRaWAN solution. We collected the requirements, and we quickly found out that LoRaWAN was the perfect solution for solving this kind of problems.
Can you more specifically share with us, when we speak about critical infrastructure, we may think again to very, I would say, legacy solution, SCADA, and other proven technologies that have, I would say, history. In terms of security, in terms of requirements, did the utility make specific requirement to you for your solution from the device to the data?
Yes, absolutely. I come from the SCADA world, so I'm quite used to this kind of integration. It's interesting to see that LoRaWAN network is seen as a complement, as a subpart of a major SCADA system that collects many other sources of data. For the pylons, for example, the customer integrates meteorological data or real-time data coming from the substations. And LoRaWAN is one of the data supplier. In fact, we normally give the network server and the database and the connection to supply data to the SCADA, to the upper layer SCADA system. Of course, this must be done in a security framework, and there's a lot of concern about this issue. Some customers are asking for a third-party penetration test of the entire supply chain. And we have worked a lot to secure the devices and the gateways and the communication part to deliver a secure and secure data that cannot be altered along its way. So we find that LoRaWAN has also a very strong authentication and encryption solution to reassure customers that the data comes from secure sensors that cannot be tampered. For example, we provide encrypted and signed firmware upgrades to the sensors. So it's not possible to load malicious software on the sensors, but also on the gateways.
We're going to finish with a question from the audience room, if there is any. I will throw a first question. What is your vision of LoRaWAN for the utilities? How utilities will continue to adopt LoRaWAN?
Okay.
Can you start?
Yeah, of course. I think this is we need to think about LoRaWAN as both a disruptive technology and a technology that needs to be integrated with legacy. So, of course, what we try to do with our customers, and that's also our capability to be able to aggregate different technologies simultaneously in a platform and manage them. We think that utilities need to use LoRaWAN for many new use cases and applications, and smart water is a typical use case that where LoRaWAN perfectly applies. But in the same time, they need to keep going with legacy technologies. It can be, for instance, wireless M-bus, Modbus, whatever. And we need to find a way to integrate, to interoperate with that. And this is, from my point of view, a key for success for LoRaWAN as well.
And you will say?
Actually, I am also thinking parallel. In some cases, we started to work with LoRa not more than 4 or 3 years ago. And we are still trying to learn and trying to manage, trying to understand what can we do with the LoRaWAN. And when we started 4 years ago, actually we could not find something like that, like today. But today we knew many things about LoRa, so I think it's time to scale for LoRaWAN. Actually, for us, we have many verticals based on LoRaWAN nowadays. On the industry side, agriculture side, even smart cities, nearly all of them goes via LoRaWAN.
And Massimo, if you want to add a
Yeah, I can say that for operators of critical infrastructure, LoRaWAN was initially either not known, fully known, or seen with suspect. For what we could do, we have contributed to push LoRaWAN as a safe and secure technology, ease of installation, and ease of maintenance. So sensors can be deployed in minutes with no wires or very limited wiring, and very long battery life. Of course, they know the limitations of a system not being real-time in a SCADA sense. However, there are so many use cases for critical infrastructure that are not strictly real-time, and they can increase the data coming from the field useful for prediction instead of just failure monitoring. We have a lot of examples in the railway applications, which is a very difficult vertical, but has found a number of use cases for LoRaWAN for sending non-time critical data that are used for long-term prediction and degradation of items and things installed along the railway track.
So to make a conclusion, we wanted here to highlight different use cases made from companies in different sectors, water, critical infrastructure, low voltage monitoring, to illustrate that it's not a question of the company size. It's not a question of the reach you can have to find faraway customers. It's not about a question to have the device at hand. Sometimes you have to develop device. Sometimes you have to be agile and to support different requirements, combining technologies. At the end of the day, those, we say, examples prove that LoRaWAN can fit out of, the main stories and main success stories of water metering. It can support variable applications up to critical infrastructures.